Hello everyone, good afternoon. My name is Alex Nichols, along with Dave Gear, Chris Canatzer. We are Project Group 15, Stormwater Agents to the Environment, or SAFE. Our project is the PSU Landscaping Rain Garden. During today's presentation, I'm going to go through just kind of a general introduction, talk about our stakeholders, and give you a project overview. Dave's going to take it from there, go into project background, talk about the alternatives analysis and our selected design. Then Chris will finish up with our hydraulic analysis, talk about the soils and plants, and the cost and scheduling of the project. Our project is located here on campus, same as Group 14's actually, they stole us above our thunder. It'll be located southwest of the library in the corner of the campus there, in the landscaping services yard. Our stakeholders for this project will be Leslie Walters, the landscaping supervisor, Megan Schneider, the education coordinator for this project, and thank them for coming out, Anthony Bohan, a project manager at PSU, and Molly Bressers, a program development coordinator, and the Capstone Group 14, EQE, who will be building their covered compost bin. So the site itself, as has been described, is kind of the headquarters of the PSU landscaping effort, where they store their vehicles, fuel them, keep kind of the general supplies they need to do their job, and the waste, there's those bins in there. Also, they keep the general supplies, or will, the mulch, soil, and compost. We kind of thought they were storing that in there already. The reason for this project, this is an excerpt from the actual Salmon Safe report. To be recertified as Salmon Safe, PSU is required to treat the runoff from that landscaping yard, the vehicle wash water, and the stormwater stuff that gets all the grit in there. The original timeline for that was going to be 5 years. And as you can see, it was a 2015 report. So just a general overview of what kind of is going to need to be done. They're going to need to make some kind of water treatment feature to treat that runoff. We have decided the stormwater planter would be the way to do that, as it's efficient, economical, and ecologically sound, since it's for Salmon Safe. As part of that, they're going to need to regrade or repave the yard. And then the covered compost bin project will be going in there as well, which originally had a deadline of 2017. And I'll hand it over to Dave. We'll talk about the project background.
Thanks so much, Alex. So yeah, I'm going to be talking to you guys about the project background, also get into the alternatives analysis, get into some of our assessment criteria, and then finally share with you guys the design we've been working on for the last 2 terms. So, going back a little ways, you all know that this is a project for the CEE Capstone. Last year's 2016 group, 5 S2 salmon savers, did an analysis on 4 different types of stormwater treatment facilities, and they chose a stormwater planter as well, and they developed that to 30%. So we, as a part of the reconstruction of the Peter Stott Center, and then the landscaping yard retrofit, this project was run again, and we decided to do our analysis on location and a certain amount of detail of that location, bringing it to a 60% design. Now, I was mentioned in the other group that we needed that access way from the landscaping yard over to the putting green, because in our first meeting with Leslie, he was pretty much suggesting that we were going to move those Connex containers over into that putting green. The schedule, I'm sure, is likely to change. There'll be a lot of pieces that need to be moved and reshuffled as a result of the landscape redesign effort, but that was one of the main reasons why spatial allocation was so important. So anyway, a little bit back, more about the Salmon Savers 30% design. They did, their options were a pervious pavement. That was really costly. It did get 100% of the runoff, but it was about $18,000 to implement. A dry well just wasn't appropriate. The vegetated swales and planters were actually very, very similar in their Pew matrix determinations, but the planter rose above because it had a little bit better infiltration. Their estimated cost is $12,405, and with an estimated 15 days to complete. I stated some of that stuff already. So I'm moving into the alternative analysis. The assessment criteria we used was, again, based on the spatial allocation. So we worked on cost, performance, geometry, maintenance, and setbacks and access. And some of these pictures show some of the major integral concepts that need to be oriented around. So you have the storm drain, the sole storm drain that services the entire landscape, services the yard, there in the top left. And the picture to the right shows a lot of the different aspects that will move. The covered tent could move this way or that way. The Connex containers potentially over to the putting green. A lot of these meetings we had was like, well, you could go here, you could go here. A lot of things are in the air, right? So we then decided our 4 alternatives were based on placement, as I said. So we have 2 with north-south placement. They're shown in these little blue blurbs. They're in the top 4. And then the one in the alternative 3 was an east-west placement, but that impeded the vehicular access of the road that would need to go over to the putting green. And then we had the south property line. Our assessment criteria were based on, we scaled them 1 to 10, and then we had our, basically a high cost was a low score, right? You know, a low cost was a high score. We weighted everything based on the priority, and cost was definitely the priority, so we put that one at 30%. Performance, we went on a flow path length, basically. So the longer the flow path, the better the score. We also went based on a percent runoff capture, which all the planters should capture more than 80% of the runoff. So then the geometry, then we scored based on minimized space used as the top score. The middle score being maybe some issues with prioritization of space, and then the last score being significant issues with the prioritization of space, wasted space, or inaccessibility. The maintenance was a lower score, because either way, we decided to do it based on hours per year, and 10 plus hours per year was based on regular weeding, mulching, and cleaning. 20 plus would be potential issues with compaction or foot or vehicle traffic, maybe walking out through it, and then all the way to mechanical failures from somebody backing into something and ruining one of the corners and such. And the last one was our setbacks and road access. Like I said, that we need that road access to the putting green, so our top score with that was vehicular and pedestrian access was unimpeded. The middle score was wasted space from setbacks requirements and our vehicular access is still unimpeded, but then the last one being, vehicular access was completely impeded and it needed mitigation via like a grate that went over the planter, which was also a really high cost. So we picked out of this one was the alternative 2, which was the north-south placement in the shape of a U, which yielded for a compact layout with a longer flow path. This graphic up here shows what we thought and we hoped that the planned compost bins would go, and then the little gray thing would be the planned generator, and the stormwater planters tucked in right in there. The flow lines that you see here, we actually did, along with the compost bin group, go out and did a simple survey to reconfirm the topography of the area, and we suggested that the flow lines, when the pavement gets regraded, to try and adjust the flow line so that the runoff goes through the compost bin and eventually is directed straight to the inlet of our planter. So here's rendering done by Chris here. That shows a little bit more, and he'll tell you more about it, but it's basically 40 feet by 10 feet, and I'll let him take over from here.
All right, thank you, Dave. So, as Dave was saying, we've got here a U-shaped planter. The primary differences here between last year's project and ours, that central wall, which provides a longer flow path for filtration, and we did some just minor adjustments in location and sizing to allow for construction and access to the new generator, backup generator that's going in for the stock center, as well as the headquarters trailer there. As you can see, we've got layers of gravel at the bottom of this concrete poured planter. We've got a 4-inch Schedule 20 PVC perforated underdrain in there that then flows directly into the current storm drain system. The only reconstruction that's going to be required there is just the addition of a taller vertical, and then we'll fill with gravel, crushed rock, sand, and soil. So a little more about the technical details here. Start off with the hydrologic analysis. The group last year did a small site analysis. We looked at the actual size of the site, including the potential new space and around the south corner, and saw that we needed to do what the Portland Stormwater Management Manual calls the presumptive approach. And so that uses the Santa Barbara Urban Hydrograph method to calculate the runoff. That's what we have here. What we found was great treatment, but poor flow reduction. I want to point out two numbers here. We've got the pre-construction 10-year flow volume and the post-construction 25-year storm flow volume. According to the management manual, that needs to be reduced from 4165 to below 1946. That's not going to happen with any reasonable sized planter that actually fits into the yard and allows you to continue to use it for its intended purpose. Anything less than about 10% of the yard area, anything that actually fits into the geometry of the space. So we pass those pollution requirements with basically any size planter. We fail the flow control requirements. And so what we looked at next was, can we get away with using a flow orifice reducer to slow down flows into the storm drain and perhaps meet the requirements that way. Unfortunately, since this site is just under 15,000 square feet, again, the Portland Stormwater Management Manual says, no, you're not allowed. We have a minimum orifice size requirement of 1 inch, and we don't believe that's going to take care of your problem for a site this size. So what we do have instead is for private owner initiated stormwater retrofits, they will allow for exceptions. Basically, they're happy if you do anything at all to improve your site. So what we can do, we can submit a waiver request form and say that, look, we're getting this pollution treatment, but we can't meet the flow control requirements, and they should allow for that to go through. The important thing to remember is that we do at least very thoroughly meet that salmon safe motivation of cleaning up the water. So, to speak a little more to the filtration aspect, let's talk about the soil plants. City of Portland, again, has very strict specifications on pretty much all of this. The stormwater facility blended soil is a blend of loamy soil, sand, compost, 30 to 40% compost. We've got a vendor and hauler list available. We'll set you up with that. Since this is a private facility, the city does not require testing or submitting results of that test to them for the permitting, unless BES looks at what you're doing and says, I'm not so sure about this, and asks for that specifically during the permitting process. As for plants, we would suggest something along the lines of a mix of Juncus, Dyschabsia, and maybe a little iris in there to cheer you up on the spring mornings. Those are all three native plants, well proven in planters around Portland, and we expect that they will do a great job of filtration as well with all of those fine vertical stems. So a brief discussion of budget. Anticipated budget again was around $30,000. As for the compost bins, but as requested, we wanted to keep it as low as possible, given that this budget is not actually currently allocated and we don't know where the money is going to come from. So to sum up the calculations, basically came up with about $4,000 for the construction process. That includes excavation equipment and labor and all of that. About $1,500 for abatement, including fencing, signage, and environmental abatement. So plugging off the storm drain during construction. And finally, about $6,000 for materials. Those are the permanent materials that are going to be make up the substance of the rain garden planter. And that will total up to about $11,500, which is about $1,000 less than last year's group predicted, and well within the budget. So a little bit about the scheduling. Don't try to interpret that drawing, just understand that it's about 3 months long. We've got, starting at the top there, permitting, setup, preliminary grading, and then excavation and framing, pouring, filling that planter. Then of course back out to the bigger site, grade, repave, and inspections. We're looking at about 16 days, 3 work weeks for the planter portion of that schedule. And we'll just need to be careful to make sure that the framing is completed as quickly as possible to allow for the curing of concrete to proceed and make sure that everything stays on schedule that way. So, given all the uncertainties, changing circumstances, again, we really wanted to try to make this siting as flexible as possible and the design as flexible as possible. That's part of the reason as well for going with a planter over a swale. You can use a smaller area that's up against the building, no setback requirement for a lined planter, and so up there right as close to the stop center as it can get. We stay out of the way of most of major renovations, so you can take care of things in the order that you need to. So, all that being said, do we have any questions and feedback? Yes.
Great job. Did we take into account the drainage from the possible putting green?
From the putting green, so what we calculated was, we did 2 separate calculations. One for the majority space, the current in-use space, and a separate calculation for the putting green. Because we didn't expect that the putting green drainage would be routed around the corner into the planter, we did look at, that was part of the thought behind the alternative 4 here.
Oh, okay.
Was that you could more readily route water to there from around the corner and putting green. That being said, that planter location would butt up against fencing issues that you've mentioned, survey problems, as well as just taking up more space at the back edge that could lead to some wasted space issues. So, I guess the answer to be brief is yes, sort of.
Sort of. Yeah. Totally. Yeah. No worries. Yeah.
What are the maintenance requirements for a planter like this?
Right. So my master's thesis down at OSU for the past couple of years has been actually working on maintaining one of these facilities along with all of the instrumentation to measure what's going on in it. The primary thing is just trimming once a year, going through once every 5 years or so, and dredging out any silt that's accumulated on the surface. We do expect to have some considerable sedimentation. We are looking at a sediment trap right at the entrance to reduce the amount of shell work you'll have to do and make it just more of a lift that tray up, dump it, and stick it back in. Aside from that, remulching and just occasional watering in the summer, which you can accomplish with a irrigation system. It's pretty low maintenance, especially once the plants are established. Those natives really take care of themselves for the most part.
Speaking of that, did we take in establishment irrigation for these plants?
So establishment irrigation was part of the materials cost, yes.
And is that just hooked to an existing, there's no existing irrigation system back there, so is that just having like a battery powered clock on that, or are you planning on hooking to the existing, to the stops clock?
Well,
Sorry.
so a battery powered clock is only going to run you about
They're like $100
yeah,
bucks, yeah.
50 from Home Depot. We can certainly do that. I had not gotten into that much detail on planning, but I'm glad you asked.